Good evening, good afternoon, and good morning, everybody. Welcome on into the Dragon's Den. How's everybody doing today? Hopefully, everybody's doing great. We got a couple of the printers in the back. Go ahead and printing some more parts for the Enraged Rabbit Carrot Feeder version 2 that we'll be working on Saturday. However, today we get to start a new build series, which is a little bit different than what we're used to because we're not going to be building one of these printers back. Instead, we're going to be building a 3D printed Star Wars droid. And it's not just going to be one. We're going to do a little series on these. So I've got the parts printed out for the D0 build or the DO build. Um, DO came out in the third set of trilogies, so the last set with Finn in them. And it's the little unicycle droid with a little cone slash megaphone style head. So we'll be building one of those, and we'll be building a 40% chopper, which is an astromech style droid that I may have shown some of you some of the parts for already. But we'll be doing a couple of those, and we're doing these smaller type droids to kind of build up kind of my chops a little bit before I tackle something even bigger. And we may even go and do a full size, astromech at some point. But I think that will be a long build series just because one of those droids can definitely really easily cost more than one or two of these printers put together. So, um, it might just be one of those things that we have to budget out and build a little bit of time and do the series on. But with that being said, let me go ahead and show you a little bit of what we have in store for it. Okay. So, kind of what you see on the table here is the majority of what we're going to be putting together here. We've got lots and lots of printed parts. Some of them are kind of small and a little flimsy. Some of them are, a little thicker, a little more substance to them. We've got kind of the main body of the droid, or at least the lower main part of the droid here, and various other small bits and bobs and gears and stuff like that, and some greebles. We've also got the couple of pieces that make up the head box that'll hold some servos and some other linkages in there. Um, the head and nose cone, they're printed in separate pieces so that you can paint it. However, I think if they gave you a good masking line that you could mask this and paint it and be able to print it all in one shot. You do see that I've got some layer separation right here. I'm going to see if I can fix this. And if not, I will reprint this part. But some of these parts get pretty thin, especially on the head. I mean, this is basically a vase mode print. And they do that just to reduce the amount of weight because the pivot joint is going to be like right down here, and then that head is going to be like way up here. So the more weight you get on that pivot joint, the harder it's going to be for it to balance that head. And so that's why some things are really beefy, like this, to enable a lower center of gravity, where other things are printed very, very thinly. And we may have to go through and try and reinforce this some and or reprint this piece. I'm going to try and reinforce it with some UV resin, where I'll brush the resin on, cure it, and do a couple of coats to try and hold it together, do some sanding, and see if we can't make this work a little better. And if we can't, I'll always reprint it with, not even worrying about it. Doesn't take that long. I'm going to put a couple of these back out of the way so I don't damage them while we're working on it. So you see a lot of printed parts here in the box, but we also have like the main tire, and this is PLA. This isn't a TPU tire. This is PLA. And you'll say, well, wait a minute, it's a unicycle. Wouldn't it be riding on this? And the answer is no. It actually rides on these pieces right here, these edges. So once we get this put together, I'm trying to, give me 1 second. Yeah, so these pieces right here will be the drive wheels, and you'll see that they stick up just a little bit on the side above this center wheel section. So these are the actual drive wheels that are going to be turning on Lazy Susans. And the white wheel will actually be spinning on some bearings that will be captured on the interior side of the wheel here. So that's kind of how your wheel's going to be built. And then you'll be able to basically take the sides off and take things off and take it all apart to get to the guts. And so this becomes our inner, yeah, the inner portion of our Lazy Susan. Our outer panels, so this would be the outer part of the Lazy Susan. This is going to go right over the top, and together, this groove and the inner groove here are going to take plastic ball bearings and will provide the rotation. So the wheel's going to rotate, but our side panels here won't. But altogether, this will be our kind of how our external wheels will go. Okay. So that's the part that we're going to be working on today. There will be some sanding involved today and some epoxy as we start to get going. I won't do any painting on stream. I will do that off stream. But we may go through and do some assembly stuff, and then I can come back and just paint like this entire piece. Because really, this piece here and really just this raised portion of the edge needs to be painted green to go along um, with the color scheme. Right? So I'll work on painting these off stream, possibly over the weekend, while we continue to build on stream. And if I need to take the wheels back apart and do painting later, maybe that's what we do. Is I'll do some shots. I'll do some videos on sanding and priming and painting, but that may be a little bit later after we get the droid build and get the build proven out that we can get its motion and everything going. And then we can come in and make it pretty, right? Because I do want to paint these, start getting into doing the painting aspect of it, because I will be doing some cosplay and other things down the road as well. So I need to start, we'll say, practicing some technique. Now, we've got these parts here, but I've also got a bunch of boxes. You might say, well, what are all these boxes? Give me 1 second and I will let you know. Okay. Mrs. Dragon. Always bringing us coffee for stream, which is good. So it keeps us hydrated and caffeinated. So our boxes here have all the other things that we're going to need to do this build. Hey, Timur, how's it going? Um, so I do have this is a kit that I've used on the dragster and um, the tank and the death racers and stuff like that. This is IXL. This is just a M3 um, socket head flathead cap screws or hex socket flathead cap screws. Um, one of these kits would be a good starting place, and then you can go out and get other things. Since I've used a lot of these already, I did go out and get some of the other screws and gubbins along the way. Now, you will need some epoxy. I don't know how much I need or how many of these I'm going to do, so I do have epoxy. This is just the Gorilla 2-part epoxy. It's 5-minute clear. Um, Technically, like a 30-minute or longer epoxy would have a better end hold strength, but I'm doing plastic parts on a Droid. 5-minute epoxy is perfectly fine. This is a highly suggested safety thing. This is a lipo safe bag. This is a fireproof bag that you can get on Amazon, and specifically to store and charge your lipo batteries in. So just in case you have an issue with one of your lipos going up, it's going to contain the fire and save you. So this is more of a safety thing that you may or may not already have. We've got a few things along the way that are a little special, like these are open here, 3mm brass rods or brass tubes. You'll need these just for some additional support. You don't need a lot of it, so just get probably this small set of it. Just make sure it's at least as long as you need it. How's it going, Otter's Danger Den? We got some of that. We got some, I believe this is 1.5, yeah, 1.5mm steel rods. Once again, just standard set of little steel rods that we'll use as dowel pins and stiffeners in the project. Might want to keep little pieces of cardboard like this. It'll make a good thing to mix your epoxy on. Because we're going to be doing electronics and motors, there's various bits and pieces of electronics that you're going to need. Speaking of which, let me pull up the website here. So Creatix Britt and I were out looking at what kind of droids could we put together and build. So Michael Baddeley is like the guy for printed droid parts, or at least one of them. He's one of the big people for doing 3D printed droids of Star Wars and other things. And printed droid, so it's printed-droid.com. Let me just go to the home here. So printedDroid.com is where we went and started looking. This is a good thing to this is a good place to get started so that you can look at the droids, see which ones you may like and which ones you might want to build. And then, of course, it'll have links because they have all the different droid types here. You've got your full-size remote control droids. Sometimes these will be more complex. Right? This is where we've got Dio. And then you'll have the mini and micro droids. So this is where we'll be building a mini chopper. I believe Creatix Brit is doing the mini cheap. But there's a bunch of different droids that are here that are really cool. So I'm probably going to do several of these down the road. And then we have some static droids that'll have, more of a display series, but can have some lights and sounds and animatronic effects on them. But when you come in here, like in my case, I'm working on the Dio droid. So you can click over here, and they've got some YouTubes. This is, I believe, off of Michael Badley's thing, and we showed this off once before, where it kind of shows the driving test of the Dio here. I don't know if mine will ever get to this level of paint job, but we'll we'll put a little work into it. We will put a little bit of work in it and give it a shot. Okay, this might help if I go full display so you can see him as he's moving around. Once again, those two little green stripes is what it's actually moving on. Right? It's not moving on the big white center wheel. It's the two green stripes, and that's what allows it to do the turning and the rotation. Greenish yellow stripes there. But yeah, that's what we're hoping to build. Um, it gives you an idea of the build difficulty. So this is advanced to expert, depending on the options that you choose. It kind of gives you a price range about what it's going to cost to get this built and done. Talks about the feature set, um, some print recommendation settings, and the needed electronic components. So what you'll see that I have is the Cytron motor controller. Switch back over here now. So we'll have our Cytron motor controller here. And this is what's going to power the larger Pololu motors that are doing the driving mechanism. Okay. Um, really nice. It's a dual channel, I think 10 amp controller. And it does, it's got good reviews and everything. So it should be good. And it comes with, some standoffs and the required connectors. Because we will be connecting this into our board, and we do not want to solder it because we need the modularity so that we can easily take things apart if we need to fix or replace something. Um, okay, so Timor, as far as the kits, the Triangle Lab kit did come in, so we will take a look at this on Saturday. I did open it up just to kind of see, took a quick gander, but I'm not going to dig into this on today's stream. But I did get the Triangle Labs. So I've got the SE Lead Labs and I've got the Triangle Labs IRCFA upgrade kits now. So I'll be able to take a look at both of those soon. Yes, Dio time. Hey, Creatix Brit, how's it going? You're still waiting for your heat sets? Oh my goodness. So we've got the motor controller. And if you have a motor controller, that means you probably need some motors, right? So we've got the recommended motors here. These are the Lolu geared motors, metal geared motors. They are 20.4 to 1 gearing. It looks so much bigger than this on screen, but these are the motors, and I like that it's written on the side where the metal gearbox is 20.4. These are 20.4 to 1 stepper motors. And then these will be where we're going to solder our wires and two little tabs right here at the top end there. I know, right? I ordered them from Amazon. Yeah, if your heat sets are still coming in, like goodness gracious, you should have bought a bunch from KB3D. I hear he's got shipping that's pretty close to like Amazon next day, or at least that's what it feels when he sends me stuff. So there's the motor driver and the motors that we're going to use to drive it. We'll need some power. So we've got a pair of lipos. These are 2200 milliamp hour lipos. And these are straight off the recommended list. So they said, get this. And I said, I'll get that. I'm not smart enough on the electronics to really deviate. So that's what I'm going to get. We've got some speakers. And these, I'm not going to take them all the way out, but these are small little speakers. You'll use two. There will be one that goes on each side of the main wheel housing. And this is what will play the sounds and stuff coming out of them. Christian Ito, welcome on in. Welcome on in. Name me a soccer player for an edit. Pele, the easy one. And like I said, I did go ahead and buy different size screws, some square nuts. I had some, but I wanted to make sure that I had all the right ones. There were some M4s. By the end of this, I'm going to have like every type of screw known to man. Yeah, M4 hex nut or square nuts. I've got a pair of these. These are going to be the flanges that we'll put on the motors. And there is a fully printed drive spur gear, but having that metal flange as the center point just makes it a little bit more robust on your drive gear. So I went ahead and went with the metal flange. So I've got two of those. I know I got another one around here somewhere down in here. Oh, look. There's the other flange. Some 683 ZZ ball bearings. We'll use these on the so the Delrin plastic ball bearings go inside the Lazy Susan. These bearings will go between the Lazy Susan and the drive wheel itself. Yeah, Ronaldo, there you go. I think I did some extra flanges. Once again, there's the plastic ball bearings that'll go in the Lazy Susan. Okay, here's the S-Spec. We'll use this to take the battery output and drop it down for the Arduinos. A couple larger size bearings. You're going to need several different types of servos. So when I bought them, I bought extras. So these will be larger servos that will be used in some of the lower portions. And then we've got the MG90S. So these are, if you've done like a side swipe or anything that really requires a servo on your 3D printer, you've probably used MS90, which would be a plastic 90-gram servo. In this case, this is a metal geared 90-gram servo. So I think this is an option for IRCFA, is a 90-gram servo, or you can use the Savic or something like that. So these are the nice, good metal geared ones, which are better for doing your droids and stuff. Once again, I bought extra in case I burn up a servo or something. I always want to have extras on hand. And it just means I've got spare parts to start building the next droid as well. So we've got our servos and electronics. And then the other thing that you'll need is some ballast. Okay. This is 5 pounds of lead shot. Yeah, it does have the warning in there for the lead. This is 5 pounds of lead shot. We are actually going to fill that center section up with the lead shot, and that's to just give it a lower center of balance to keep it from flipping over on its nose cone. Okay, so these are all the electronics and everything that we're going to be putting in here to make Dio work. Well, almost all the electronics. And I say almost. Let me put some of the stuff back in here. I think I'm going to put basically the electronics and the balls in there. And I'll leave this stuff out because we'll have to get into some of that a little bit more here. But I went ahead and did an option. So there's an option. The gentleman that runs Printed Droid does have some optional electronics for some of these builds. One of those being DO. So to make my life a little bit easier, I did go ahead and buy these. They come out of Germany, but this is the power distribution board, and literally its entire purpose is to be able to plug your 2 batteries in, and that puts them in series, and you can specify whether you want the XT60 or the Dean T connectors installed. Either way. And then the screw terminals here are used to send power to the motor controller to the switch. So you'll have an on-off switch to cut power on or off to the whole robot. One will come out to the Cytron motor controller, and then the other one is what will come up to the SBEC and go into the Arduino stack. Now you will need an Arduino for this, but the other half of the boards here is the Dio all-in-one Nano 1.5 board. And so this will be a hat that will sit on the Arduino Uno, right? And it's going to give you, let's see, this is the Arduino Nano that's used for the sound processing. We've got the Cytron motor. Your signaling will come through here and go back out to the motor controller. We'll have the 2 speaker inputs are these screw terminals. This is the step down for the power. We'll have the power in, the step down that applies the power to everything else on here. Maybe I don't need the SBEC. I'll have to double check. Your receiver, if you get a standard receiver, would go here. If you have an iBus receiver, those are really, really tiny, like this size or smaller. Then it would plug in at the 3 here, and you wouldn't use the servos here. It would go right into the iBus receiver. And then this piece up here is where some of the magic happens. This is the oh, what do we call it? The MPU, but this is basically the motion sensor that will help do the self-writing. So as he starts to move forward, it will self-write um, the head unit and keep it stable. So this is, think of this as your gyro stabilizer. Okay. Now, each one of these boards, it tells you to buy, and then you would wire it all up. What this does is reduces a lot of the wiring. So instead of having to do a bunch of crimping, I can bring stuff in directly to the screw terminals and reduce the amount of crimping and wires that I then have to shove in the uh, uh, the body of the robot. And if you go to the printed droid link and look up the stuff, there are links to Michael Badley's videos, and I will find the link and post it. But he goes in and talks about, like, he starts disassembling it, takes the head off, takes the sides off, and starts talking about the electronics. And you'll be able to see the rat's nest of cables that's in there connecting all of this stuff up. Well, having a printed circuit board makes it easier to do the wiring. So it's a little more expensive, but it'll save you a lot of time doing your wiring down the road. So, and I'm all about having good solder joints and stuff like that. So, not that I question my soldering because I do enough of it with the 3D printers, but if I don't have to, why would I? Right? Um, so with that said, that's a good overview of the project. Hey Pete, how's it going? Welcome on in. Sorry I missed you there for a bit. Um, so with that said, there's some printed PDF instructions. There's a wiring diagram. You may see me bounce back and forth because I do have those printed instructions laid out. And they kind of go through the steps a little bit here about, what's needed, your printing guidelines on how to do your prints. Definitely something good there. Your kind of big electronics list here. And then it gets in and starts talking about the assembly. Now, there's also an online manual, Dozuki manual. Dozuki is just the manual type of page. It's what like Prusa uses for their manuals, and I think some of the like zero G and boron stuff, Dozuki as well. And so this, I guess, let me just go full screen again, and we'll chat through this a little bit. So the nice thing with the manual here is it does have links to the Patreon page. It also should have links through here to possibly some assembly videos and other good resources. You would definitely want to go out to the Facebook page, which, what is it? Let me go ahead and open this up. Yeah, Mr. Badly Printed Droid. Very good Facebook group to go out and join, as well as the Discord if you're going to start printing any of these droids out or any of the static, animatronic type ones. Definitely go out there, join these. They're great people. They'll help you along. Okay. But we've got kind of some basic sets here. We'll have the Lazy Susan assembly, which is basically setting up your wheel rims. You'll have your frame, the main frame assembly, which is the main inner portions of the DO unicycle piece. You'll have the head box and neck assembly. That's literally the neck and this white head box piece up here. We'll do some top frame and electronics wiring. and then closing everything up. And we'll do some testing along the way and stuff. Otis, how's it going, my friend? Welcome on in. Welcome on in. We've just been kind of going through where we're at and all the printed parts and bits and gubbins and electronics and stuff that we're going to use for this build. And then once again, it's fairly straightforward. Once again, it's going to start off with here's to the Patreon page and stuff like that. Now, the nice thing is these files, right? This is how hard it is. Go to Michael Badley's Patreon page. His lowest tier is $1, and it gets you access to all the files. That's literally how hard it is. $1 for 1 month, you can go grab the file. I would highly suggest staying around and throwing more than $1 at them if you really like the builds and can afford it. Because there's a lot of great things in the tier, and I don't think he really paywalls a whole lot. Oh, cool, Fotis. Thank you for stopping by before you head to bed. All is well. All is going well. Like I said, we're going to do a different type of build series on the stream. Right now, we're going to go through and do a droid build series where we build a Dio. We're going to build a mini chopper to go with Creatix Brit's. I believe she's doing the mini cheap. And there's probably going to be other builds that I will do along the way just because they're kind of cool and kind of fun, right? Gives me something that I can print to have fun with, basically. So we're going to work on some of these. There may be some things that I will skip and come back to later because once again, I may do some sanding on the stream for part fitment, but as far as external and parts prep for painting, that will be done probably most likely off stream. And I'll go downstairs, put on the proper gear, sand a lot more in depth. I will prime the parts, I will sand them, and if I need to, I will prime a second time, sand them a second time, then paint them, and so on and so forth. I will be using rattle can spray paints. I got them all downstairs, but I believe I got the Rust-Oleum 2X, both the sandable fillable primer, the meadow green that they suggest for the green parts, and I've got a bunch of gloss white and gloss top coat that I had already bought for the Mandalorian, the Imperial Mandalorian Commando armor set that we still need to do on stream as well. So yeah, we got a lot of good projects this year that will not be 3D printer builds, but will be related to 3D printing. And Fotis, I still need to look for a DM from you or just DM you to talk about possibly doing a boron build for you. But come back over here. And so the parts required, we need some M3 square nuts. So we'll have those here. Kind of grab some stuff and move some things to the side that we don't need right away. So we will need the M3 square nuts, which are these. Get some of the M4 stuff over there. And M3 by 10 and M3 by 8. There's M3 by 10, M3 by 8. And we'll need the 6833 ZZ bearings, which are right there. So we'll get this stuff over here. The rest of this stuff we will move out of the way for the time being. Just move them over there. Printers become good horizontal surfaces too, by the way. So the four pieces that we have here will be the, list them out here. Yeah, the printed parts. So we have a drive edge. This is the drive edge. The inner Susan. Okay. So we'll need two sets of those. So drive edge and inner Susan. And then we'll need the outer Susan, which will be this piece. Once again, the outer Susan, our groove is, say, groove to the inside. The inner Susan, our groove is kind of outside the part there, easier to see. And then our skins. Okay. So that makes up one set on each side. And there's a note here that says, after test fitting the 10 millimeter bearings, they were too tight. He went with 3/8 inch Delrin bearings. And I believe those are the bearings I got were the white ones that I have are the 3/8 inch Delrin. So if I need to, and those are too loose, I'll go ahead and order the 10 millimeter bearings. It's no big deal. It shouldn't take too long to get here. So we'll start with the outer ring and the outer Susan. So we'll take the black parts and just move them off to the side for the time being. And we're going to need our two outer pieces here. And I've got this piece of silicone mat here because as I start to do some things with epoxy, I will want to do it on the silicone mat because that way if I get any squish out, it's no big deal. I can clean it off here real easily. So this is a silicone mat for that reason. So you'll be matching the outer ring with the outer Susan for both the A and the B side. Test fit them together to make sure they connect together flush and there's no printing issues or areas that need to be sanded, trimmed to fit, or what have you. What they're looking for is your inner and outer piece should basically pop in together. And be flush. So just like that. And if you need to do any sanding because something's bowed up or not sitting all the way flush, now is the time to do that. And I'm getting a little bit of a rise right here. So what I can do is I need to look and see, is there a seam on either side or just a spot where like the print, I don't know if this will come out on camera, but you can see that there's a little bit of awareness to the print right there. And that's what's causing it to bow up. So just take a little bit of sandpaper here and sand that smooth. Probably do this with some paper towel over it so I don't get sanding dust all over my mat here that I'll be using in a little bit. But you'll just want to look for those seams and the joints. Look for your Z-seam or any other imperfections and just sand those down. This is an internal surface, so it's not going to be visible. And even the part of this that shows isn't going to be visible because there will be a plate that sits over the top. And that is sitting down in there nicely. There's no edge. So that's all we need to do is just sand ever so slightly. We're gonna join these two together. So once again, this outer edge here, we can sand down to prep the surface, and then we'll paint this to give it that glossier look, and then we can weather it. Um, but the this inner piece here is going to be covered with the outer plate, right? So we don't need to worry about any finish here other than just making sure that our screws are good. So what I'm going to do is just get both of these kind of prepped and ready and make sure that they're sitting down nicely on top or within each other. And I don't have any like raises or bumps. That is looking good. And once again, this channel right here is where the ball bearings are going to ride in. And check that for smoothness as well. And especially look for your Z seam, as you might need to sand it where that Z seam is at to make sure that it runs really smoothly. But once again, go easy and lightly because this particular section right here is not very, um, it's robust, but as it comes up to this edge, it's not. So it comes together or it comes up here at a nice sharp angled point here. So be careful that you don't knock down that edge. But you want to watch out for pieces like right here where that seam is and make sure that it's sanded down smooth and that your bearings will glide on the inside of these. Now, the other thing that I did, it was suggesting, I believe, a 0.2 for most of these parts. These parts that we're going to have the Lazy Susan bearings riding in them, I printed these at like 1.6 or 1.2 layer heights just to make sure that I got nice, good, smooth um, layering there for those, rather than trying to just say, let me do it as a 0.2 and then I'll do a lot of sanding. I went lower than the recommendations. It just takes a little bit longer to print, but it's easier in the long run by doing it. Right? It just saves you on a lot of sanding and prep. Hey Ozzy, how's it going? Hey Shaudell, welcome in. We are going and starting the process of doing our build for our Star Wars DO droid, which is the let me jump back here. It'll be the whoops, didn't want to do that. There we go. It's our unicycle droid. So take that away. So it's our little unicycle droid here. And that's what we're going to be building on stream here. So we've got both of our outer parts prepped, right? Um, let's see, test fit them together, make sure there's no fitment issues. Sand or trimmed as needed to make sure that they fit well. Mix up some 2-part epoxy and spread it on the inside of the outer ring, and then put the inner piece in it. After basically coat both parts, snap the pieces together, and put something heavy on top of them. So once again, we're going to be mixing up some epoxy and then putting them together and putting a weight on them. So actually, probably my other silicone one isn't as thick, but it will be bigger. So let's go with this mat because I have a feeling I'm going to need more space to set some parts out after we get some things started on epoxy here. It was almost a bad day, folks. I almost knocked over my coffee. That would have been bad. Once again, I do have the printed instructions so that when I go downstairs and start working in the garage to do some parts prep and stuff off stream, I'll be able to follow along in the instructions there as well. So we'll have our 2 ring parts here. And once again, it's going to be wise to have something that you can mix your epoxy on, you can toss away. So any box, this is just a box from one of the Chaotic Lab CNC taps. These will be great to just mix up a little bit of epoxy that we'll need to join these 2 pieces together. And then once again, what I might do is put one there, put the other mat on top of it, stick this one on top of it, and then put something heavy on top of that to press both of them together at the same time. That could be an option there as far as weighting everything down. So I'm going to pop this out, maybe. Pop this out. There we go. Nice tight fit. And we want to put epoxy on the inner ring and on the outer edge here so that when we put it back down in there, it's going to actually have epoxy in both places. Hey Pez Liz, how's it going? Once again, as shown here, where we're putting that inner race piece and then getting them put together and putting something on top to weigh them down and setting them aside. This is 5-minute epoxy, so it should set up fairly quick. And once again, the nice thing is it's basically pre-mixed. You squirt it out. Well, not pre-mixed, but you squirt it out, and it's 1-to-1. So you're not having to sit there with some epoxies and figure out and weigh out ratios and all that good stuff. In fact, talking about little mixing things, that might be useful for a mixing trough later on as well, possibly. Okay, so let's double check here with our instructions, which say prep your work area, be well ventilated, remove plastic stir stick from the middle of the plunger. That's good. Remove plastic stir stick from the middle of easier said than done. There we go. Got that out. Now it says hold it upright to break off the top piece. Eliminate air, dispense even amounts of resin hardener to a clean disposable contained surface. Package itself can be used as a mixing tray, blah, blah, blah. Mix both parts for about 20 seconds to make sure it's mixed real good and then start applying. Okay, sorry, just trying to figure out to make sure that we can use it and not waste a lot of epoxy when we do this. So once again, hold it upright. There are little air bubbles in there that we'll have to get out the air bubbles. Just pull this off. Twists or just pulls out. I think pull out or break off. It says remove the closure. That's I don't know if it I think it just breaks off. Broke off. And it says to squeeze out the air bubbles, both sides. Give it a little squeeze, try and get those air bubbles out. Finally got it to move and then it squirted everywhere. So that's good that I had it over stuff. We'll clean this up a bit. Okay. And we're just going to dispense a little bit out. Pull back on the plunger a bit. Put the cap on. We'll wipe it off and then put the cap on. Oh, put that over there. Might be a good idea for me to actually put some gloves on too. Got some craft sticks here. We're just going to use this and mix our hardener and base together. I don't know how much of this will go around, so I'm trying not to make like a huge batch and then wind up not needing all of it and just wasting a bunch. Definitely could probably use a good chunk more than what I dispensed out that time. That's one edge. The inside edge of one, the outside edge of the other. Looks like probably should have done more. Case in point, for the next time, we'll do some more. Hey, zombie, how's it going? Lurking and cooking, okay. Mix some more here. We'll try and mix a little bit bigger batch this time because we'll need to do both, finish off this wheel and do the next wheel. Once again, we have a 5-minute set time on this. So we need to make sure that we get it well mixed. Does mean swirl it around and hold it up on itself as well. Make sure you're getting it nice mixed. You could also be doing this in little cups. You know, it talks about using epoxy here. You know, I hadn't thought about it, but I wonder if something like 3D gloop would work as well. One, 5 minutes isn't a huge time, but it's not a oh my God, let me rush either. So just take your time, get your epoxy spread evenly. with the, oh, we got the one there, the mat on it. That right on top of it. And we'll add some weight, like 5 pounds of ballast. And we'll definitely want to try and clean up. Like I said, if you get a little bit of epoxy on there, don't worry about it too much. It's silicone. It should come right off once it dries. So 20 till they should be done. Hey, Subsector, how's it going? Subsector, we are building a DO droid from Star Wars. He is the little unicycle type droid. Um, so this little guy. So we'll let those go for a little while. They'll be epoxied. The next step is to use the inner Susan and the B print along with 12 M3 square nut. So this will be 6 on each side. And these will be the slots that we see all the way around the corner edge. Okay. So we have these like that. And we're going to put in 12 M3 square nuts. So we'll need our square nuts. Hey, Karen Clark, how's it going? Welcome in. Welcome in. The subsector, it's been a while. Long time no see. Hope everything's going well with you. Now, these may be hard to fit in. They may be easy to fit in. If they're hard to fit in, just make sure that you press them in and get them lined up. If they're loose, you can use a little bit of, they always suggest hot glue, but you could also use, some CA glue to hold these in. In my case, they're pushing in fairly easily. Oh, this one. Okay, so there you should be able to see all 6 of the M3 square nuts are put in. So we'll leave 6 more on the other one. This life, well, that happens. Um, how's everybody doing on the West Coast? Because I had some people say that there's quite a few people on the West Coast without power right now in California. Okay, so there's 6 in there. Once again, the like standard Suzuki, there's the picture that shows, hey, here's where you put your 6 nuts in. And once again, if it's a tight fit, use something to push and pry them in. If it's a loose fit, add something to help hold them in place. Moving on. Before finishing the assembly, now's a good time to go over the parts and do any sanding and painting that will need to be done. Once again, the only thing that really needs to be painted is this lip right here. A little bit on both sides. So paint this lip right here. Once again, I will just take this off and repaint it later on. But anywhere that you see where some rough printing, see if I can get got some rough printing here. I may go ahead and just slightly, sand the edge here to get some of that done. Once again, I was using uh, very low layer heights on these just to try and make sure that everything was easy to get smooth after the fact. And I didn't need to do a lot of sanding to get rid of, 0.2 layer lines or 0.3 layer lines. Um, and I printed all of this in PLA. So if you did something like ABS, you could use some power tool, but using PLA, do not use power tools. You'll do more to melt it than to sand it. Yeah, I'll just go around these edges just a little bit, just to get them a little bit sanded down. And like I said, this edge ring, I'm going to wind up painting green down the road. Okay, I'll just take it back off and paint it green. I'm not going to worry too much about it right now. I just want to focus on kind of building it and put it together. So the most important place to check for required sanding is the raceway for the ball bearings. Once again, that's on this piece, and it's this outer rim right here. So if you've got sharp spots or burrs in here, this right here is where you want to really focus on sanding and getting it nice smooth. I don't know if it shows up, but I do have some roughness in here. So this is where I want to sand. And get the balls of your fingers down there when you do that sanding. Once again, it's a channel that you're going to have plastic ball bearings in. You don't want to make a crease in it. You want to smooth out any of the rough edges in there. And you don't need to go in here with like 80 grit. I think this is 400 grit that I'm using right now. Just looking to make sure that trough where those plastic ball bearings are going to ride is nice and smooth. And we'll add a little bit of grease in here and possibly a little bit of PTFE oil as well to allow the bearings to roll very nice and cleanly in here. And this hole here, by the way, this is where you're going to put your bearings in. So once this is in the other piece, this will be a closed off tube, and you'll insert your bearings from the inside through this hole and just work them around in here until they're completely filled up. So work on these, make sure they're nice and smooth and that you're not getting any ridges and stuff, because you don't want these things to start hanging up after just a little bit of use, and then you wind up having to disassemble everything and maybe reprint parts. And so you have a Delta. Well, weren't you working on the Delta, or trying to think, did you buy the Delta or did you have to get it and repair it? Yeah, I have some people that I follow that are over there. And yeah, I saw some of the flooding that was going on, and it's pretty bad. But this is 220, so what? FL Sun Super Racer. Okay, very nice. Ah, darn. Okay, there we've got our Raceway, nice and sanded down. May, May, I am going to wipe them down a little bit, just try and get rid of some of the dust from the sanding operation. We don't need a bunch of sanding dust in there to interact with any grease and basically make it, turn it into a paste. So now's the time to sand down the outer ring, sanding down the entire channel for the bearings on your print, because no printed part will be perfectly smooth. Correct. Now is also the time to sand down the outer ring prints and drive edge prints to prep for painting. Plan on painting them. How much you sand is up to you. Yes. So here's where he goes through and he does his painting. Once again, I will do this a little bit later. I will do this off stream because I'm not going to be spraying up here in the Dragon Den. Oh, well, that's what this is. We've been building a trident on the Saturday streams, and we'll do a little bit of building on this this coming Saturday, which is my birthday stream. And while I'm on that topic, so apparently I've got family that decided to call and let me know that they were going to be coming over on Saturday. So we'll start streaming at 10. We'll do a little bit of building and electronics work on the Trident. And at noon, I'll open up the form and we'll start doing the prize giveaways for the stream. And I need to wrap it up by 2 because that's when my parents and my brother and sister-in-law are coming down from Virginia. My parents are coming out from Goldsboro, and I guess we're going to go out to uh, late lunch, early dinner. So, oh, manager left, so you became a stucky. Oh, is that what he did? Was he canceled his stream to celebrate my birthday? Well, that's so nice of Steve. Um, Once again, I had already had a bunch of the Rust-Oleum 2X, so I picked up a can of the Meadow Green to do the outer ring print. And once again, I'll have these together, but I can always take them back apart or mask things off. And I need to spray this edge. So just this outer drive edge needs to be sprayed green. Spraying all this, just waste spray paint because it's not going to be seen, right? Um, and once again, he says, living in the Midwest in the middle of winter, it's getting up to like 50. So what I'm going to have to do is go out in the garage, spray it, and then bring them back inside to dry, and then go back and forth, back and forth, back and forth during the day. So I'll take my lunch break, go out and spray. Then right after work, go out, stand, probably spray again, and bring them back in to fully dry. Oh yeah, no, I can't. I cannot inflict my parents on you guys. Can't do that. If you're painting the parts, make sure to wait until the paint's fully dry, which I will do. Um, We're going to use the drive edge A and B and the inner Susan A and B and some M3 by 12 countersunk screws, 6 per side. So we start with the drive edge and the inner Susan. So that'll be these pieces. Once again, this being the drive edge, this being the inner Susan. With the near side of the inner Susan down on the table, place the drive edge, protruding edge up over the inner Susan, lining up the round countersunk screw holes with the square nuts. So kind of hard to do, but we've got round countersunk screw holes here, and we need to line these up with the square nuts. So it's going to be like that. Use the M3 by 12s into each of these to join those together. So 3 by 10 and 3 by 8, coming in 3 by 12. So let me see what else I have here, or just grab my, I don't know if I got M3 by 12s or not. Flange, 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 magnet, 4 M4, 4, big bearing, another flange. So M3 by 12s coming out of here. Of course, and that would be the size that I am almost out of. Apparently, I misjudged, and I need more M3 by 12 countersunk screws. So we will have to order some of those and possibly move on to some other aspects of the build if we need any more than that. 3 by 12 countersunk screws. Line these up with the holes. And we'll just work our way around. Again, we're lining the screw hole up with the M3 screw that's through the back there. And I just said I don't have a drop one. And I'll have to find that one. I don't know where. Kind of thinking like M3 by 10s would actually fit these here. Yeah, I'm definitely going to be short. There we go. Black ones there. Not going to have enough to do all of them unless I switch to a different size. But goes down, this comes over the top. Now I'm going to skip every other one on this one. So I'm going to have to try and overnight or prime the remaining M3 by 12 screws that I'm going to need. You have a few thousand spare if you need it. Yeah. Well, like I said, I will order a great googly moogly of them. Like I said, the tens may work. I mean, looking at them, I think the tens will work. So 4, 6, 8, 10. Those were 12s. Or for that matter, going up and doing 14s might work as well. See, one's engaging, but not very much. Actually, probably a 14 and see if a 14 will get me there. Not stick out. And so then we'll just finish out with 14s. Yeah, 14s look like they'll go, so we'll use 14s for the last three in here. I'll still order some M3 by 12s just because I know I'll need them for something. Obviously, I'm out of them, so okay. So those are done. Wind up with. We'll attach the bearings. So we'll use 12 of the 683 ZZ bearings and 12 M3 by 8 countersunk screws. Okay. These are our ZZ bearings. 3x8s, and when we're done using them, I'll just dump them into the pile there. So how this is going to work is we've got slots on each side. Bearing falls down into the slot, lines up, and then countersunk screw goes in through the part and through the bearing. Seals. You might here, just like that. So, and this is what um, the outer wheel, or the outer wheel, the center wheel, the white center wheel part actually will ride on these bearings. These are just into plastic, so don't try and drive them home. You need these to spin freely. These M3x8s are basically just lightly going into plastic, and they're becoming a bearing surface. Makes for a pretty nice little mechanical build, and these pop in pretty nice. So once again, you can follow the print minimum requirements, but like I said, I printed a lot of my parts at a finer layer height resolution than what they called out, simply because I wanted to have less sanding to do to get things done here. Hey, Subsector, have a good day. Oh yeah, Greg is sitting there talking about my parents. Yeah, they can pop off with some funny stories, but it's like they don't like give them freely. Like you got to catch them off guard, and then they'll let a funny story out, and all of a sudden they'll be like, "Oh, did we say that?" Yeah. You can heat them up and let them cool. But yeah, all of these bearings are now in there, and so once again, your wheel is going to go right on there. This outer edge of the black part is what it actually rides on, but the wheel is going to spin on those bearings. Okay, so that wheel spins on those bearings. So we'll go ahead and we'll do that for our other one to get all the bearings set into place on this one. Oh, yeah, I've got plenty of extra screws for dropsies, and I will be. I've already dropped one of the M3 by 12s that I'll have to go look for a little bit later on. These, I didn't see that problem over here, but it looked like the holes have like a support on them, so you can't see through them. So I'm going to hit those real fast. These are M3s, so I'm going to hit them with a M3 reamer because I do not want to open them up. I just need to clean them out. I'd probably hit them with a M2 if I had a 2 mil reamer, but I don't. I just have an M2 drill, and I definitely don't want to use a drill bit. I'd much rather just use a reamer. Not going to take much to get through these. But the reamer does not enlarge the hole, which is why I want to use the reamer. All right, try this again. Now they're not going to grip at all. It proved problematic. Feel like I definitely needed a 2 millimeter now. And these screws aren't going into anything right now. They're just straight through. They're not grabbing into anything, so I can pull these screws right back out. Wonder if I should try and go with pens and see if I can't drive them in there, or like tap them through the backside. Either that or the other option is a tiny dab of CA right at the uh, screw hole there. We will work that. Next. M4 nuts. M4s? No, M3 nuts in these two slots on either side of the hole. Once again, this is going to become um, the Lazy Susan bearing tubes. M3 square nuts. Yes, magnets are pretty good. I don't have any big magnets. Try and easily. I guess what I need to do is get one of those shop roller magnets. That would probably make it a little easier. These drop down right in there with no problem. Might have to use a small dab of hot glue if they go falling out of here soon. Okay, so he did 3/8" Delrin bearings. But the outer ring assembly on top of each drive assembly is shown in picture 2. So let's pull our weights off. I'm pretty sure that our 5-minute epoxy has now set pretty darn well and is not going to come off anytime soon. And these will sit right on top of here. Once again, creating our Lazy Susan. And it talks about installing 62 bearings on each side. So let me grab my bearings. For those of you that remember this discussion from before, I still have not found those other bearings I was looking for, by the way. And I'm probably going to want to count these out. Make sure I get enough in there. Give me 1 second, folks. I'm going to go grab a little container real fast. Okay. Grab a little container, and what we'll do is we'll count out the 62 bearings, and then we'll know how many go on each side. So 2, 6, 8, 10, 12, 14, 16, 18, 20, 22, 4, 26, 8, 30, 8, All right, so there's 62 bearings. We'll set it on top, put in a bunch of bearings. I guess I'm trying to see how they stay together before I go putting in a bunch of bearings. Okay, so we got the Lazy Susan set up. That's basically what we did in that step. This step, 62 bearings or 58 if you're using the 10 millimeter. We'll be inserting them into the hole, feed the bearings one at a time, push them in using the next bearing to push the previous one in until they all fit. The final bearing will be sticking out. You can use a screwdriver or pretty much anything to get it all the way into the channel. All bearings installed, your assembly should look like picture 3. Add the plug. I guess I'm confused because at this point, even if I put bearings in here, I'm trying to figure out how. I guess the bearings are going to hold the two halves together. Sure how that works, but okay, I'll agree to it if that's how they say it works. Now, the other thing is I may wind up putting these, well, I'm going to take them apart anyhow down the road because I need to paint stuff, right? Either that, yeah, I'll be painting stuff. So I will take these apart down the road, but I do want to see this stuff go together. Um, Now, before I get going, let me find those other two small parts that will be the um, kind of the plugs. There's one. There's the other. So and it was kind of looking like it was, a point, but it's actually got the groove in there. Might need to clean that up some with a little bit of sandpaper just to make sure that it will not interfere with the ball bearings. Basically, our ball bearings are going down in that gap between both pieces. Okay, we're going to set that on there. Through this hole, we're going to go ahead and feed in all of our bearings. Going to make sure to keep this clamped, but not super duper clamped, so that these can go in and kind of move around a bit. Really, really hope that I do not put this in a position and then fill all these bearings out while trying to put them in this. The void lays claims to screws. Yep. The void and carpet are the bane of my existence when it comes to screws and nuts. Cannot express how many of those I have lost only to be found like days later as I'm walking around barefoot up here. Hey, Pez. So it's pretty interesting that I'm dealing with my balls and bearings and I don't have gloves and lubes out, huh? Normally when we start playing with the balls, I wind up with gloves and lube out. Rotate that just a little bit so that I'm not having to deal with this piece here. Yeah, the adult innuendo. Huh. Thank you. So the hope is that with having the balls, my plastic bearings, otherwise known as balls, in the channel here that it's filling up the channel and holding these pieces together, right? Just lifted this whole thing up off the table. So that's basically what it's doing. It is the balls are holding both sides together. There's a little bit of looseness here. Like I'm thinking 10 millimeter may have worked for me. So I may still wind up getting the 10 millimeters and trying them. Okay, and that is all 62. Now we take this piece, this little U-shaped plug, stick it in there. And put two M3x8 screws in there. M3x8, right? And these will secure onto those on those square nuts that we have in there. And this will hold our ball bearings in there. And so once again, I will wind up taking these off or at least masking this off so I can spray. This is how once again, this is the drive wheel. This will pretty much stay stationary and our drive wheel will roll. That's one full wheel set up there. Okay, so let's grab our other piece I just threw on the ground, because that's what I do apparently. And we will do the same thing and get this piece put together. And like I said, at some point I'll dump all my balls back out and we will do some prep and paint on these, and then we'll get the balls back in there. And when I go to do that, I will probably, like I said, do a little bit of like white lithium grease on the inside around here, just to help them be a little bit better as far as the balls and lubrication go. I'm going to grab two more of these screws out. Those over there. These up. And we'll get some more of our balls out here and count them out. Or we can just start putting them in there. I mean, I guess it'll hit 62 easy enough. Really? Three, 4, 5, 36, 7, 8. Hey, Britt, how's it going? Fifty, 2, 3, 54, 5, 56, 7, 58, 9, 60, 1, and 62. That should be a full set of bearings. Then we'll take our plug again, use our M3 by 8 screws to secure the plug, therefore keeping our bearings in place. And it is the bearings that are holding these two halves together. And how's it going, Britt? Yeah, you came into balls and lube. It's funny how that always happens. So the black half and the white half are now held together by the 62 plastic bearings. And as you see, I mean, they're pretty smooth. A little bit of play. That's why I'm saying the 10 millimeter bearings might be better. Either that or, like I said, adding a little bit of lubrication as well. But that bit of play there would get to me. So I think I will go ahead and order the 10 millimeter bearings and we'll try that out. And once again, that will give us, ample time anyhow. We'll keep working it this way, but we will need to take these back apart at some point to paint. Yeah, runaway bearing, runaway bearing. And apparently, if I go up to the 10 mil bearing, I only use 58 per side. So I use 4 less per side going with the 10 mil bearings than I do right now. So that'll be fine. But just like that, there are our two outer wheels done until we rip them apart to do more painting. And got the bearing hole, and the Lazy Susans are complete. We'll give the author, but not if I have to sign. I will do that. And next up will be main frame. So we will take this stuff, which was some epoxy, and set that stuff aside. We're going to take our two Lazy Susan builds. We'll be able to move this to the side. But once again, our, oh my gosh, what did I do wrong here? I know what I did wrong. So I put these on backward. Luckily, we can change that without taking any bearings out. Do these. And do 6 screws. We'll just flip this inner black ring around. Get your balls on, or get your gloves on, and lubricate your balls. And so once again, all we're going to do is take this and turn it around. Line it back up on our holes. All of a sudden, it's going to look a lot better. So, Britt, you were doing cheap, correct? CH33. You were doing cheap. I was doing chopper. Oh my gosh, we need to um, post that link for a Droid because those were so flipping cute. That makes sense now. We do take this one off and swap it around. It's going around and doing every other hole right now because that'll help keep it centered and keep it from bowing as we move around. Tells me I'm going to get very good at putting this together and taking it apart. So Pez, you said you got your shirt. What did you think of the shirt? Because I haven't gotten much feedback other than just me, myself, and I on my shirt so far. So how this is going to happen is here's one side, your main wheel goes on it, then your other main wheel goes on it, and that is your rolling wheel. So yay, that would be Dio's wheel. And once again, you're riding on these black rims. Let me see if I can get close and you can see that they stick up just ever so slightly above everything else. So you're riding on the black rims, which will be painted green. Okay. So that's your donut. That'll be the donut. Hey, Shenanigans, welcome on in. Now we'll start working on the main frame. So we'll need a few pieces and parts and gubbins here. Printed parts would be the main frame, mainframe insert, Palulu gear, AB, main bar, main servo gear. We'll figure all that when we get to it. Screws, square nuts, lead shot, epoxy, paper towels, a lot of other stuff. Important information. Just want to let you know I made a mistake with building this. He bought cheaper motors from Amazon that looked to be similar. They're much weaker, had all sorts of problems. Yeah, even with the Pololu, people were saying that they've had problems where it looked like the drives were not moving at the same speed, and they've had issues where like a motor like doesn't even start to kick in until it gets like a high voltage. The whole system's set for 14 volt, but if once your batteries start going down, like you have to give it some juice, otherwise it doesn't get started, or one of the motors may not. So we'll have to see there. So here's where we start with the main frame, this piece, and the two 500 RPM 12 volt motors. These are the Pololu motors. We'll grab those with encoders. The motors I used are here. You also need 4 M3 by 10 countersunk screws. Using two M3 10 millimeter countersunk screws per motor, attach the motors to the main frame as shown. Repeat the process on the other side of the main frame for the second motor. Now, the one thing that I'm not seeing here is it's talking about installing the motors, but it doesn't mention wiring. Right? It doesn't say anything about how much wire or wire length to use. So he talked about how to wire up the motor, or how he wired up the motor, and that's, once again, we're going to wire up to these two tabs. And one of the tabs has a dot right there. And it said red, but that looks black to me. Take a look at the other motor. Same thing. Mentioned red. That dot does not look red to me. That looks black all day long. So we're going to use a red and a black. And I'm going to jump real fast to the wiring step real fast and see if it talks about the wiring gauge. He used motors with the encoders built in. I didn't. So if you're using motors with encoders, you would have connection. I don't. So we'll be going. So for giggles, I'm going to wind up using some 18 gauge wire. And well, I guess we'll go ahead and we can install these now, and then I can take it apart and do the wiring on the motors themselves, simply because I don't want to do any soldering just yet. I do want to get some new silicone wires. So the silicone wire I have, um, I'm out of the red and the black in an 18 gauge. And I think I want to use like 18 or 20 gauge for this silicone wire, just to make sure. In fact, let me look at the. Let me look at the other instructions here to see if it actually talks about any of the wiring. Because encoder versions are not needed, but you can get the ones with the encoders. So it's great. It has you put everything together and then come back and do wiring later on. Yeah. So in this case, it talks about and it shows doing the wiring. Because I have the wiring diagram here, but it doesn't identify any wire gauge to use. So I'm going to have to take a look at that, because that's a 10 amp dual channel 10 amp DC motor driver. Shenanigans. You probably know this. Would it be best to use 20 or 18 gauge wire for that? my assumption is going to be 18. Yeah, that's what I was thinking. And I would really want to use red and black for the majority of the power and negative. And that's what I don't have right now is red and black 18 gauge. Um, yeah. So I'm going to need to get some wire in order to start wiring these up. And I'll probably need to get it together with some of the electronics to figure out wire lengths and then, you know, take it apart, solder it, because I'm not going to try and solder it as it sits in here. Um, so yeah, let's, whoops, get back here to mainframe assembly. Well, it's like everything else. We put it together, we take it apart. We put it together, we take it apart. We're going to take our two motors and we're going to use M3 by 10 countersunk screws per motor and mount it to the frame. The M3 by 8s, these are the M3 by 10s. Why is it not cutting? Because you didn't pull the blade out. And once again, these will slide in. Round so that the mounting holes go. Really? There's one started. And as mentioned before, we'll have a motor here, motor here. The batteries go in these two big wells, and then each of these smaller cavities, we're going to put ballast in to add weight. So this whole bottom area down here is open. So we're going to add ballast down here underneath everything to add more weight to the bottom. We'll have a motor, and then this cutout here on each side is for the speaker wire or for the speakers. So look at this, it's just test fitting. And I mean, that's going to give us plenty of room for the wires and stuff for there. And once again, I've got a couple of pieces that are going to make this easier for the wiring as well. Get the process on the other side to get our motors installed. Yep. Then we'll assemble the drive motors attached to M4 by 3, attach 4 M3x10 long screws, M4x3 square nuts, low load gears. Okay, these are for the fully printed gears. And I don't have the fully printed gears. I've got the gears that go on the flanges. Okay. So that's where I'm going to need my flanges. These have screws. No screws, but there is a set screw. A couple of set screws actually. So good news. Okay. So I may have to flip over to here because this doesn't talk about the option for the metal drive gears. Flange coupler is more substantial. Using the flange coupler, take the coupler, 4mm flange coupler, fit the printed gear using M3x8 and M3 square nuts, 4 per gear. Bolt the coupler to the gear as shown. So M3x8 and square nuts. Huh? That's kind of weird. Like why you would use square nuts instead of different type. Well, I guess use the square nuts because that's what we had. So countersinks here. So we're going to go through there. With that. Sorry, I'm looking at the diagram and in some ways it doesn't make much sense. Because here I'm sitting here thinking with the way that we're doing this, why would I use countersunk screws, which it obviously looks like a countersunk screw in the diagram. That's an M3x8 right there, and it's not even making it all the way through because of the countersink. And oh, because I'm using 8, it says 10s. I actually used the right size screws. Guys aren't catching it. Guys aren't calling me out for missing things like that. Oh, hold on. You're using the flange coupler. Use M3x8 and M3 square nuts to bolt the coupler to the gear as shown. I don't think there's any way it's going in that. At least not with them 3x8s going through. 3x10s get me there, but once again, I'm not sure why I would use flange and or a countersunk screw on a flat surface versus a button head screw. This is where I'm going to take some maker/builder license, and we're just going to grab some button head screws of an M10 type. And so get there. Now let's see if our square nuts work or if I need to work with X nut. These might not have enough edge clearance to be used. That'll work. Moment later. So once again, these are M3x10s. Not sure if 8s would work cleanly there. I mean, it does come through a little bit, but not much. 8s wouldn't go all the way through I don't think 8s would get through the threads on, or the threads on the nuts. They're going to clear the printed part on the back, or they'll clear the face on the back, so should still be good there. So Creatix Britt and I had decided we were going to build droids, and this is from Michael Badley's collection. So Michael Baddeley, he's got a Patreon, and I will post all these links in the VOD and in the YouTube export. But if you go to printed-droid.com, okay, once again, it's printed-droid.com. Let me go ahead and grab that and dump it back in here. How do I do a pinned post? OBS. Yes, yes, this is what let's see. Oh, there we go. So yeah, so Michael Baddeley is a guy that Sam Prentice deals with. And same thing, you go and you can pay $1 to get all the Baddeley files. And these are under the, oh dear God. So All right, sorry, I just saw your thing, shenanigans. The voltage, these motors are 12-volt motors, um, going into a 10 amp controller, and that controller is going to be sitting like right up here. It's literally like 6 inches. Right. Hey, Westry, how's it going, sis? But yes, printedDroid.com is a good place to go. And that's where we went and decided which droids we wanted to work on. And like I said, uh, bup, 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 English. So printedDroid.com, they're a good site. They let you see a lot of the different builds, but they will direct you back to Batalay's Patreon to go get the files. Okay, and I've been a Patreon for Batalay for a while because of the Death Racers. Um, so you can go out and you can get all the different files. They've got a knowledge base here, but you can click on droids and it will show you all of the full size remote control droids. And these are the full builds. And I'm doing the Dio droid over here. Whoops. And but you've also got, the full size chopper, the full size cheap, B2 EMO from the Indoor series. You've got the full R series of astromechs, so R0 to R4, R5s, B11s. You've got the Dio BB1. You've got, I believe, the BB8 and BB9 is there. And then you've got the mini and micros. So that when I go to do the chopper, I will be doing the mini chopper build. And I believe Britt is doing the mini cheap, CH33P. Yeah. So he's got all kinds of little droids in here. And of course, when you go to these droid pages, they will, um, tell you the recommended print settings, what are the features of it, what's the difficulty and the estimated cost range, um, what kind of electronic components you'll need, where to get things. Once again, Michael Badalay's Patreon, the Facebook group for Badalay's droids. And yeah, so, and once again, this gentleman does have um, some boards custom made. So I did order these custom set of boards. So I didn't need to get the Arduino and a bunch of this stuff because it comes on the board. And I got the power distribution board as well. So my batteries will plug right into here, and then I'll come out to the switch, to the motor driver, and then to this controller board. So I'll basically jump her from here to here, and then this is the step down buck converter for everything on the. Hey, Daddy Wazzy. So it just makes wiring a lot easier. But okay, so we've got one flange set up. We're going to do the other flange. Once again, the flange goes into the recess side, and I'm using M3x10 button head cap screws just because I think they sit in there a lot nicer. And we're going to go ahead and continue to use the M3 square nuts. How's it going, Daddy Wazzy? Hopefully you're doing well. Yeah, these are cool little projects. And of course, I still need to do my ISS tracker project that you showed off. I'm like, dang it, you got to stop showing these off because now there's something else I need to add to the build list. I think I need to get a huge shopping list together of all the electronics that I need. And so when I go to Rocky Mountain in April, I can just swing by Micro Center and see what I can pick up. And of course, there's supposed to be a Micro Center opening in Charlotte, which is a little bit of a drive. It's not too bad. I mean, it's like 2-ish hours, if I remember right. Which is better than the 4+ hours to get up to my brother's. Now, I just noticed, not sure if you guys can see, but I've got a little bit of elephant foot on these gears. I don't think it's going to matter. I think they'll wear down pretty quickly, but I may have to clean these up a bit too. So it says the first thing to do is insert the square nuts into the Palolo gears, but that would be to attach them to the motors here. And what I'm going to do is they come with teeny tiny set screws. So we'll be using the set screws that came with the flanges to mount these on the motors. And yep, want to use some uh whatchamacallit, Loctite on these. And hopefully I don't put one of these down on the ground because that would so there's two set screws on opposite sides. Nice thing is we'll do one against the flat of the motor. The other one will go into the round edge of the motor shaft. And I may have to turn the motors a bit. Get some easier access to the shafts. Once again, we take the flange, put it on the motor shaft, and I believe we're going to drop it all the way down. Or at least that's where I'm going to set it right now. Do the first set screw. And we'll do the other one. Well, we got it here before we rotate the um, motors again to get to the other side. Yeah, so these are really, really fun builds. The other cool builds would be like the 3D sets RC cars that Steve Builds is doing on his stream, or was doing. I was that his I think that might have been his members only stream. Can't remember if he's doing it on the but 3dsets.com has RC cars and you can either build them static or full. I think they're like 1/10 scale RC cars. And it doesn't say where these go, so I'm assuming that we will get them initially on here, kind of like we do all of our motors, and then we'll line them up with um, the actual drive mechanisms. Speaking of which, it at least has to clear this side here. This is a herringbone pattern on these motor gears. So they will only go in there kind of one way. Or I don't want to say they'll only go in there one way. Um, they will line up on the drive pieces here only one. Was one side tightened? I gotta rotate around to get the other side. Once again, these are pretty tiny set screws, so don't crank on them for all they're worth. We'll strip them out and then have a bad day. Next up, oh, there we go. Align the flats of the motors to the top, which is what I did. Front side is also the side A for Lazy Susan. Keeping track. Lining up the hole for the screw on the gear with the flat of the motor. Attach the gear to the motor. Rotate the gear to the other side and attach the second screw. Make sure it spins without wobble. If there is wobble, you can adjust the wobble by adjusting the screws. Yeah, so the herringbone pattern of the gear is pointing inwards on both sides. And regardless, if I switch these flanges around, they're still going to be pointing towards the center. So we're good. Take the servo base print and insert it into the center of the frame. Make sure it is seated fully and flush into the base of the servo base piece. This piece. And I'm assuming that this is only going to go in one way. We've got this sloped edge, and we've got this sloped edge on this side and a straight flat edge on this side. So this will only go in there one direction, like that. Once again, just going to say, holding it like this, set it down on the edge there, line it up, and let it fall down in there between these pegs. Now in this step, we'll use an MG996R servo. So those were the bigger servos that we had. And once again, all the servos that we're using are Metal Gear servos. So they should be long lasting and they should work better in here than a plastic geared servo that would most likely strip out. There's bit bobbins, mounts for that. Let me clean these up a little bit so I don't make a mess. Got our servo. Boom. Epoxy. Part we're going to need. That one. Main servo gear printed part, the center screw for the servo, the round servo attachment, and two-part epoxy. Round servo piece means these others can go back in here. The center screw I will assume will be the one odd man out screw. These will be the mounting pieces. That stuff. Very small amount of two-part epoxy. Spread it into the center bottom of this. boxing this with this flange coming up from the center, not going down through the so it doesn't go down through the printed part, it'll come up from the center, that. Allow sufficient time for the epoxy to cure as when working on it and attaching it to the servo. You do not want the gear to be angled or not spin with a gear to the servo. You be done installing frame, which is next. One thing I want to see, did mention using a screwdriver. Hold it firmly in place. Big, that'll be too big. Here, there's a little bit of play in this piece here. So if it's not fully centered, then I may develop a wobble in the gear. I have to slather this and then hold it centered in that back hole while it cures. That'll be fun. Me grab something that I can use to mix up a little bit of epoxy stuff away so I don't get it all epoxied up. One second. Well, Miss Dragon, I was going to need something for smaller things and get me some of these skewers. And up and some air bubbles in, trying to knock them up. There, I want to. Don't need a lot because this is really not a big part that we're trying to um, do stuff. So we just need to mix a little bit. Probably would have been better to use hard plastic or a different plastic rather than this, but we're going to get the job done. Mix for about 20 seconds. All this there. That in there, and I'm going to center it, pressure, and sit here and hold this for minutes. So this is 5-minute epoxy. We'll wait a couple of minutes, let this start to set up. It'll be like blowing and make sure the bolts aren't missing. Yeah. Bolts are there, grub screws are there, Loctite's there. That sit there and continue to harden up. Meanwhile, we'll just take a gander through. We've got a few minutes that we have to wait anyhow, so they wait with some purpose in the fact that we will um, wait with purpose in the fact that we will go ahead and read ahead and see what some of our next steps are going to be. Again, I purposely put this silicone mat down here so I can clean it off later and roll it back up and put it up without messing up my table. Next, we'll attach the servo to the frame. Use the screws from the servo pack and the main frame. Insert the servo into the center of the main frame, lining up the drive sprocket with the hole in the side of the frame. Okay. What we're seeing is this set of holes here. We've got two on this side, two on this side, and then one hole there. That will be for the drive sprocket. So put this down in there, making sure that everything lines up. Insert the servo into the center of the main frame. Hole on the side of the main. Attach the servo to the main frame using the servo screws shown on picture 2. Holes in the side of the main frame are for the screwdriver to go through, tighten the screws. Okay. Okay, I see. It's not held right up there. It actually goes, it's mounting to these ears on the side. That. Probably be better if I printed this part not in black, huh? Now the question is, do I use the, do I put the um, rubber pieces and use the grommets? I'm not seeing, doesn't look like they used the rubber or the grommets. They just went ahead and did screws straight into the plastic. Everyone think, should we put the isolator grommets in? I think we, I don't know if it really would do anything in this application. Why not? Why not? Do just like that. We'll set this back down in there. Need those 4 self-tapping screws. Other plastic servo horns in there. Oof. Go on there, through the whole thing, doctor or whatever. Operation, game operation. Screw it in, self tapping into the plastic. Last one, I did a crossing pattern. And once again, this piece, it's going to drive the gear for the head. So that's why we're using that big beefy servo. Just spinning there for like 7 minutes. Just a little bit longer. Put the main gear onto the servo and use this screw to screw it in. And this inner, the inner piece has like a gear um, thing to it. That makes sense. So that will align with the teeth in the gear on the servo motor itself. And then we'll screw that in and screw it down. And I don't know if you guys can tell, but there is kind of a little cutout divot in that lower printed part that that gear kind of aligns down into. Once again, we'll take the screw, feed it through the hole in the front, line it up on the servo, and attach it. Okay, there, now it's up. There you use 12 M3 square nuts and 2 M4 square nuts for setting up the main frame. Per the pictures on where to insert the square nuts, all arrows in red are M3, all in green 4. Okay, that looks like it's going to be fun. M3 square nuts. Okay. Looks like one here, one on the side, one on this side, one more over here, and I just lost. Yep, I'm losing them. Darn it. One. I'm going to need to get some. One, I'm going to need to find these, and then two, I'm going to need to get a I was going to say a hot snot gun, but hot glue gun to attach these in here. At least make sure that they'll be hot tacked in there and go anywhere. Good news is I found a couple of screws. So the ones on these sides that are at a weird angle, I'm not going to be able to install those right now. If they're somewhere where I can get to them and install them, and they'll be horizontal, I'll go ahead and install those now. One here, whoops, one on each side. And then on the back, same type of thing. Two at the top, this. These are pretty loose. And one, two, and three. Or if these will be tighter. Oh, nope. So we'll have to get a few of these. So it's one, two, three, four, five. One, one, two, three, four, six, seven. 8, 9, 10, 11. Oh, okay. So all three more down at the bottom. We have to put some hot glue in some places. Two M4s go here. So M4. As before, the nuts will most likely press fit into place. If they don't, use some uh, glue to hold them in. M4s might be thick M4s instead of thin M4. Oh, I didn't know what it was. Hey, Justin, how's it going? I am excited for Murph. I am super duper excited for Murph. So let me see if this is just some whatchamacallit, elephant splitting, because this was printed this side down. So this could just very well be some elephant split that's causing me not to be able to get these M4 nuts pressed in. And that's obviously what that was. So elephant's foot, and get the M4 nuts in there. Um, like I said, I'll bring the hot glue gun up here a little bit later. That's no big deal. Not using the resin. I used the full print file, so I'm going to the next step. Here you'll use the front frame insert and the rear frame insert. And I know that there's elephant's foot here because I just felt it, so I'm going to clear that real fast. How about you, Justin? Are you ready for Rocky Mountain? You're probably ready for it to be over already. Joys of managing a show. By the way, the cottontail parts are coming out really nice. A couple more to print. We'll be going on to something else. Okay, so we've got these two parts. And darn it. Again. What do we need now? Front insert has two pockets for the M4 square nut. Really? Ah, there they are. Going from the inside edge, looking on the outside, going, really? I can't find them. M4 square nuts from the inside of that piece. Two M4 square nuts. and 4 square nut shoved in on each side, lined up with the holes. Okay, we'll need these two big um, jiggers, bearings. Insert bearings into the frame insert. On the back side. And I might have, yep, a little bit of elephant's foot there that I need to clean up. Pop right in there. Get out the hole these bearings go into with the light standing on my Dremel to get them to fit snugly. Make sure they insert all the way in. There's a small lip on the printed part. Stop the bearings. Yes, yes, yes. That is how we are looking. And folks, I think this is where we're going to stop for the night. I need to get some hot glue and we'll hot glue some things in here. Once again, we're probably going to have to take these motors out so I can solder a length of wire on them. And I don't want to go too much further before I get that done. Yeah. Well, we've made good progress. We've got our base going pretty well here. We've got our side wheels done. So once again, these are Lazy Susans, 4 printed parts. The motors that we have installed here are going to line up with these tooth gears on these big black pieces. I will need to take these back apart and spray paint these edges green. So what I'll do is I'll take these gear pieces off. I will tape up around these bearings and just spray it green. So those will be good. And then these parts, of course, I can, in order for me to take these back off and spray paint them, I would need to pull all the bearings out, which, like I said, there's a little bit of side to side shimmy in these. So I'm going to do that anyhow so that I can go get the 10 millimeter bearings, which will be a little bit bigger, right? Which should take up that play. And then, yeah, I think that's the best thing to do. So we'll be working on these, maybe not just yet, but I do want to take these apart and I will be spray painting these and sand them, prime them, sand them, gloss white, 1 or 2 coats. And then later on, once we're all done, we'll add some clear coat to it. But yeah, there's just way too much play there. And once again, this whole piece is going to sit in here. So I'm going to keep losing. Um, It's going to sit in here, and there's your gear sitting in that channel. Okay. So you'll have one gear there, your um yeah, yeah. All right, I'm gonna lose them. Let me just lose them the rest of the way. Okay, so the ones up here all stay. When I was looking, I'm probably gonna have to pull these flanges out even more. No, maybe not, because these are gonna. So these three screws are gonna mount into the sides. So that's why we're putting the screws there. So this will mount into the side. That's gonna line up. Wheel goes on. The other side, once again, will go on. Line up with the gear. Line up with the gear. So that's basically how we're setting up right now. Okay. And once again, these little tabs here are going to screw into those M3 nuts that we have there. And then there will be the weight here. So this is the whole thing that's moving on our Lazy Susans. Okay. So yeah, that's kind of what we got going here. But for now, I'm going to clean up. Let's go ahead and get ready to raid out. Oh, hey, Westry One, welcome on in. Welcome back on in. So we've been trying to get everything set up and get our gears and make sure our gears are meshing. I could probably move the gears back out just a little bit more so that they're more in line with the tooth running gears there. Now they're a little bit insert or inside, and because there's that herringbone pattern, we really need to make sure that they line up well. So you need to move them out like this side's good. This side needs to come out like a millimeter, maybe two. So I'll work on getting this one aligned right. And like I said, we'll work on, I'll order the other bearings so that we can get these swapped out. And, I'll work on painting, might have to wait until the weather gets a little bit warmer. It's just kind of cold. And I really don't want to sit there and have to spray paint it, bring it inside, spray apart, carry those parts inside. Because every time I move them around, there's a chance that they're going to get messed up. So I think we'll just wait on painting until it starts warming up. We got plenty of time. I mean, I don't have a designed timeline for Dio being done, and the um, chopper is scheduled for East Coast Rep Rap Festival. So me and Creatix Brit will have our droids there. So that's our collaboration builds for Earth. So I think with that being said, folks, I'm going to go ahead and raid us on out. And I do want to raid over to Creatix. She hasn't been on the last couple of times. So I'm going to go ahead and set us up to go over to Creatix Brit. Thank you, everybody, for being here and hanging out with me for this droid build. Like I said, it's something new, it's something different, something we haven't done on the stream before. So thanks a lot for being here. We will see you guys again on Thursday, and we'll continue to work on this. and see how much further we can get on it there. Like I said, it's probably going to be one of those things where I put it all together and then take it all apart to do the painting and stuff afterwards. But oh well, that's the way it goes. Thanks everybody for being here. I'll see you on Thursday. Don't forget Saturday stream. We go live at 10. We'll do a little bit of building, and then at noon we'll do the prizes. And then 2 o'clock, I've got to be done because I've got family coming into town to take me out for my birthday. So thanks everybody. We'll see you later. Have a great week. Bye now.